Okay, so I think we shall start now. Please confirm whether my voice is audible or not and my screen is visible or not. Okay, let me share my screen. My screen is visible, right? Okay, so welcome to the live interaction session on computer integrated manufacturing course, which is instructed by Professor J. Ramkumar and Professor Amandeep Singh, and I am Chinmui, a primary scholar from IIT Madras. So this is the last, that is 12th week of that course, where we'll be seeing the assignment questions which are being solved in previous as well as these years on the 12th week of that lecture series, which is based on computers in manufacturing industry. That is the current scenario of that. So basically the contents of that lecture includes modern computer-based technologies, that is Industry 4.0, then artificial intelligence, machine learning, deep learning, digital manufacturing, smart manufacturing, IoT, that is Internet of Things, cloud-based manufacturing. So we'll see the questions, we'll try to solve, and first of all, I'll give a brief overview of that, and then we'll see the answers and explanation of those questions. So basically, if we talk about Industry 4.0, that is that modern computer-based technology. So it's basically like we can say it's revolutionizing the way like companies manufacture, improve, and distribute their products. Okay, so like manufacturers are integrating new technology, we can say for example Internet of Things, cloud computing, analytics, then artificial intelligence, machine learning, so those things into their production facilities and in their operation also. So this is how, just a minute. So this is how we can say the smart factories, so which are equipped with advanced sensor, then embedded softwares and like robotics, which collect and analyze data and allow for better decision making. So this is how the manufacturing companies are improvising themselves. Okay, so even like higher value is created when data from production operation is combined with operational data from like supply chain, customer service, other enterprises we have seen in previous lectures, right? So like even that digital technology due to industry 4.2, we can say it leads that increase in order of that automation, predictive maintenance, and even self optimization or process improvements. So that is how the efficacy also has been increased, we have seen. So like basically what it does, like using high tech Internet of Things, that is IoT device and smart factories. So it actually highs productivity and improve quality. So even what it does actually, basically it replaces all the manual inspections with artificial intelligence powered visual insights. Okay, recently we're seeing even that the impact or importance of AI, right, in every field, rather than manufacturing, also in our daily life, also we are seeing so many AI applications with that. So what it does, like it saves time, saves money, saves that manufacturing errors, that manual errors, it reduces. Okay, with minimal investment and quality control. Just a minute. I'm not audible. Hello? Hello? Just a minute.
Am I audible now? Hello? Can you please confirm whether I am audible or not? Hello? Can you please confirm whether I am audible or not?
Audible, ma'am.
Okay. Okay, fine. Sorry for the inconvenience. Okay, so what I was talking about, that the importance of industry 4.0 or new technologies in manufacturing. Okay, so basically what it does, actually it is like due to that smart factories or developing smart factories, so basically it provides actually an opportunity to the manufacturing industry or manufacturers, we can say, to like enter to the fourth industrial revolution. So it what it does, it like analyze large amount of data which is basically collected from some sensors or embedded softwares through, so on the factory floor, which ensures real time visibility. So real time data analysis we can able to do in industry 4.0, okay, on factory floor. So what it does, it provides tools for performing, we can say, predictive maintenance, so that like minimize basically that downtime, equipment downtime, it minimizes even those manual errors, or also the time, it saves time, money. So you can say, like, even in today's world we are seeing this applications of AI, right? We are seeing like that AI, like AI powered visual insights is possible in every field, like rather than even manufacturing also. So the manufacturing errors are getting reduced. Okay, so from, like, we can say that first industrial revolution in, like, in 18th century, so we know those things, like the first industrial revolutions, like, which basically helped mass production by using water and steam power instead of like purely human and animal power. So then come to the second industrial revolution. So later, I guess a century later, second industrial revolution like introduced assembly lines, use of oil, gas, then electric power. Then like comes to the third industrial revolution with 20th century. So it added actually a computer or advanced like telecommunication processes, then data analysis to the manufacturers. Okay, so then next it comes to the fourth industrial revolution. So now what is our like recent trend which we can tell in manufacturing process, right? So where we can say like it increases automation, we can see, because like you can analyze the data with the help of artificial intelligence or machine learning, right? So smart factories and like in like data helps to produce like goods for more efficiently and productively. Just a minute. Okay. So even like collecting, if you collect more data, say for example from factory floor, then you combine with the other enterprise like operational data, so a smart factory you can achieve, right? From like, and the information will be transparent and like better decision we can get, like both the like both the manufacturer and the enterprise, like we can like make a best decision among them. Okay, so basically the technology, like in behind that industry 4.0, what are the technologies are there which are driving that industry 4.0? That is, one is internet of things, that is we call as IoT also. Okay, so internet of thing basically we can say is a component of like smart factories. So machines on basically in factory floor we can say like those are equipped with sensors, right? So it features like an IP address, so it allows the machine to connect with other web enabled devices. Basically what it does, the sensors are having that features that an IP address, so it allows machines to connect with other web enabled devices. Okay, so connectivity is possible here for large amount of valuable data. So large amount of data you are getting to be collected. Okay, and also like you can analyze those data and exchange those data as per your requirement. So this is the case, this is the first technology we can talk about that which is driving the industry 4.2. Then next one is the cloud computing, which we have seen in the lecture notes also, right? So in cloud computing we can say like, you can say it's a it's a cornerstone of any like industry 4.0 strategy. So like where you can get a full what you can say, you can get a full realization of smart manufacturing. So it demands the connectivity, it demands integration of engineering, then it demands supply chain production, it demands sales, it demands distribution, it demands services. So cloud like makes it possible that large amount of data can be stored and analyzed more efficiently and cost effectively, like with cloud. So cloud computing even like reduce that startup cost for small medium sized manufacturers. Okay, so basically who needs that right size their needs and scales as their business grows. So then next technology which is driving that industry 4.0 is artificial intelligence and machine learning. Okay, so basically we talk about, right, artificial intelligence in manufacturing, AI in manufacturing. So what it does, like it actually, the companies nowadays, it takes the full advantage of AI, we can say, of like volume of information, so generated not just like on the factory floor, even across the unit even they are using. So what it does, like artificial intelligence say machine learning, it creates insights, like provides a visibility and predictability. It actually predicts based on the his past history, or can say based on the some trained model or tested data. So it actually predictability is possible here, and like it automates the operation and business process. So even for example you can say like industrial machines are there, their breakdown is a very common thing, we can say. Those are prone to breaking down like during production process. So using data collected from these assets, like these machines, we can say it can predict the health of the machine, right? And it is and that it can predict, and it can tell you that when the predictive maintenance of that machine tool will be needed based on that machine learning algorithm. So isn't it like it's very easier to do nowadays to tell like, okay, before even like breaking down, it is telling you that no, your machine needs a predictive maintenance based on that machine learning prediction data. Okay, so this is the most important technology, we can say, that which is driving that industry 4.0. Okay, then edge computing is there. So like real-time production operation means like some data analysis so should be done at edges, right? So that is where data is created, we can say. So it minimize even the latency time for when like data is produced, we can say. So even detection of safety or quality issue which requires real-time data, right? So this data is needed to send the data to the enterprise cloud. So for that edge computing needs, look, so data stays near its source, like it reduces the security risk, we can say. So that is where the importance of edge computing. Okay, then comes to the cyber security. So like manufacturing companies are not like having always considered importance of like cyber security or cyber physical system, but the thing is that we can say like connectivity of that operational equipment in factory, so those actually enables more we can say efficient manufacturing processes. So when like undergoing a digital transformation to industry 4.0, it's actually essential to consider a cyber security approach that actually encompasses that IT and OT part, Internet of Things, like, okay. So then comes to the digital twin. Just a minute. Okay. So the digital twin is basically is like a transformation, we can say. So it is like offered by 4.0 industry 4.0, which allows like manufacturers to create digital twins which are like virtual replicas of process, so production lines or factories and supply chain. So it's created by pulling data from IoT sensors, devices, PLCs and other objects which are connected to internet. Okay, so manufacturers use the digital twins to help increase in productivity or improve, which basically it's a replica of that process. Okay, virtual replica, we can say. So by like analyzing that replica, you can say manufacturers like increase the productivity, improve workflows or design new products. Okay, so simulation of a production process, like for example, we can say manufacturers, even like an engineers, can test the changes to process to find ways to minimize downtime, okay, machine downtime, and or improve capacity. So that is where the importance of digital twin. Okay, so even like, so basically smart factory, the main characteristics or main motive of that smart factory is data analysis, like for decision making, optimal decision making, we can tell. So sensors, embedded softwares, interconnected machinery produce, so those like produce a significant amount of big data for manufacturing companies. So data analytics, like it helps the manufacturers like to investigate the past history data, right? So that a decision can be made, a better decision can be made based on the with the help of artificial intelligence or machine learning to predict the data based on past history. Or we can say, just a minute. Now it is clear. What is digital twin? Actually, as I have told, basically it's like a you can say it as a virtual replica. So what it does, by analyzing that replica, you as an engineer or you as a manufacturer can decide like, okay, I need to like improve the design of that, or I need to improve productivity so that I can minimize the machine downtime, or I can minimize the manufacturing downtime. So basically, by you are analyzing that virtual replica, and you are making the decisions that, okay, based on the analyzation of that virtual replica, you are telling, okay, I need to improve here, I need to improve the workflows, I need to improve the design, or I need to simulate some production process, like test you will test the replica and you will change the process. Okay, I'm changing the process so that I can find a minimum downtime here, and I can improve the capacity. That is how that is what is digital twin. Okay,
Ma'am, can we call it as virtual prototype?
yeah, you can call, like, you can tell like that
Yeah,
also.
thanks.
So like the next one is so where we are like we're talking about the characteristics, or say for example, like for that of that usage of that smart manufacturing, smart factory, sorry. So data analysis for optimal decision making, which we are talking about, that is like complete digital representation of operation can be created, like as a digital twin, we are telling. So, right, so then IoT integration, that is smart manufacturing, smart factories network architecture, which basically depends on interconnectivity, right? So real time data collected from like sensors, devices, machines on factory flow, it can be consumed, right, and used immediately by the factory assets. So, or like shared, it can be shared other across the other component in the enterprise software stack. So even like planning a enterprise resource planning, that is ERP, which we have seen in other lectures also. So that is how it works. And even custom manufacturing, so basically what it does, like smart factories, just a minute. Okay, So basically what it does, smart factories produce like customized good, even which meet like individual customers need. Okay, say for example customer to customer your requirement will vary, even cost effectivity, so you need to maintain the cost effectiveness also. So in many industry segments we can say like manufacturers like achieve lot size of one like in an economical way. So using that simulation software applications like material or technologies such as 3D printing, manufacturers easily create small batches of like items or as per the like particular customer need. So that is how that industry 4.0 is all about, that mass customization. Okay, so and that is what like then the next one is that what we have talked about, that artificial intelligence. So how like artificial intelligence can be applied in manufacturing. So we can say like artificial intelligence and machine learning like are giving manufacturers and like ability to like predict the data, optimize their supply chain, we can say, and accelerate the research and development part. So like for example we can say the defect detection. Say for example like if you see in manufacturing, any manufacturing industry today, we can see even like in many assembly lines have no systems or technologies like in place to identify defects across the production line. Okay, so and like in a assembly line which is going on there, you need to find the defect in that production line. So it requires like skilled engineers to build and hard code algorithms to differentiate between functional and defective components. Okay, so it is like quite ambiguous, right? So for that like for if you incorporate artificial intelligence and self-learning capabilities, because it is having the self-learning capabilities, because it is taking the past history data or like even supervised and supervised data. So it has that capability of self-learning process. So it saves countless hours which are like wasting here in finding the defects in production line. So it is reducing the false positives or like hours required for quality control. Then if you say see for example in quality assurance, so actually manufacturers or say for example manufacturing process, it requires actually attention to detail, actually in fine detail we need in manufacturing process. So history quality assurance has like was past in past it was a manual job actually. So but day by day when AI is introduced, so like nowadays image processing algorithms, if you see, it's like automatically it validate whether an item has been perfectly produced or not. So even like if you can see by using image processing also, if you say for example I have seen somewhere like in stack of bottles like glass bottles, it checks quickly, that algorithm quickly checks, or that sensor quickly checks that whether any defect is there in that line or not. So any defect product is there means it will quickly detect the defect product and it will just remove from their production line. Okay, so those processes are being very easy due to those artificial intelligence, say for example image processing, machine learning, those things, right? So if you install the cameras at key points in the factory floor, so like sorting can happen automatically in real time itself. When the stack will come like one by one, the product will come, the camera sensor will detect, okay, this product is is having the defect, so it will just like separate it from the line. Okay, then assembly line integration. So like even like much of equipment that manufacturers use like stands of like amount of data to the cloud. So those like in that also like in assembly line optimization, so by layering in artificial intelligence into like IoT ecosystem, so you can say the wealth of data, so you can create a variety of automations. For say for example if you see like when equipment operators are showing like signs of fatigue, or supervisor gets like notification, so those things like it can break down that process, and its systems like automatically trigger contingency plans or like other recognition that activities. So that is how, like, even like from manufacturers are getting the benefit from AI. Like in cobots we are seeing in like work with human, okay, collaborative robots also called cobots, we can see, we have seen like nowadays. So it frequently work like alongside human workers, right? So while autonomous robots are programmed to like repeatedly perform one specific task, so cobots are capable of learning various tasks, so they can detect and avoid obstacles, even agility, then awareness, which allows them to work like alongside with human workers, okay. Then so those are the like digital twin, then again to help the in boosting that performance, right? So digital twin, like you can say, as I have talked already about, that a virtual model of a physical object, right? So it receives information about this like physical counterpart, like through latest like smart sensors. So using artificial intelligence and other technologies, we can say. So digital twin like helps deliver insight about objects. So companies like then monitor an object throughout its life cycle, and like it get like critical alerts such as need for inspection, maintenance. So those alerts also manufacturers can get, and they can accordingly plan their activity. So for example, even you can say it's like sensors are like attached to the engine, which will transmit the data to engine's digital twin every time like the plane takes off or land. Say for example, sensors are attached to the airplane engine, okay. So it provides the airline and manufacturer with critical information about engine's performance. So that airline can use information to conduct like simulations and anticipate the issues. So that is how it helps in boosting the performance, right? So now we like even in predictive maintenance, like improve safety or it lowers so manufacturing plants, then railroads or other heavy equipments, we can say. So those there like users increasingly like they are using artificial intelligence based predictive maintenance, okay. So to anticipate serving needs. So like say for example, if say for example one equipment in the manufacturing process, like in manufacturing industry, you can say, is not maintained in a timely manner, right? So companies risk lose like time or money. So they waste like money and resources if they perform machine maintenance too early, right? So uh, whether like to avoid ignore that too early maintenance, and to avoid the risk of like after that breakdown, machine breakdown also. So to avoid those things, like predictive maintenance comes into our picture, like using artificial intelligence, as I have talked about it, that it predicts the it takes the data, and based on the like history data, it predicts that okay, your machine it predicts the health of the machine condition, okay, your machine needs a maintenance or your machine is going well. So that is how it works, okay. So basically those like certain machine learning algorithms are there which detects like patterns or that triggers manufacturing to ramp up the production process, right? So even like if we say for example the types of artificial intelligence which are there, like here one is supervised learning, where like systems are able to predict future outcomes based on past data, as like we have discussed about some examples previously, right? So it requires both input and output to be given to a trained model. Like it needs to give a model some past data, needs to give a give the model, so it will predict the future data, okay. Future outcomes can be predicted like way by studying the past data, okay. Then unsupervised learning, where systems are are able to identify hidden patterns from input data provided, okay. So in whatever the input data will be provided, it will basically the model will identify some hidden patterns or some interrelations between the input and output data, okay. Based on that hidden patterns, it will group the data, and like similarities, it will find some similarities or anomalies in the learning process, so it will predict the output according to that, okay. And then it comes to that reinforcement learning, where like systems like are given no training, okay. It learns on basis of reverse or punishment it receives from last action, Okay, it helps like increase the efficiency of a tool or function. It basically it works on the basis of like which rewards is it is receiving from the past action. Okay, basically no training model are there to like know about the data. So those are the types of machine learning model you can say. And if you talk about deep learning, like deep learning like is a part of like broader family of machine learning only. So where it is inspired by the functionality of brain cells like called neurons. Okay, so even we are like we have heard about neural network, right? So which led to the concept of artificial neural networks, right? So input layers and hidden layers will be there. From that the output layer will be predicted. Okay, so now we'll see like some questions, then we'll again come to the discussion part. So one question is given as artificial, the first question, that is artificial intelligence helps allow machines to gather and extract data, acknowledge patterns, learn and adapt to new things or environments through machine intelligence learning and speech recognition. Okay, just a minute. Yes, so as you said correctly, that is the true statement, right? So basically what it does, as we have discussed about that, artificial intelligence like aims to create, we can say, machines which are capable of intelligent behavior, like designed to perform tasks like that require human intelligence such as perception, reasoning, learning, decision making. So basically one of the key features of artificial intelligence is like ability to gather and extract data from various sources. Like it uses the data to learn and adapt new situations, right? So it enables like AI systems to identify patterns in data, like make predictions, decisions based on those patterns, right? So that is how that the yeah, it is correctly said, the statement is true. And the second is one is the fill in the blank is there is the use of an integrated computer based system comprised of simulation, 3D visualization, analytics, collaboration tools to create product and manufacturing process definitions simultaneously. So what will be the correct option for that? Any guesses? So anyone?
Digital manufacturing.
Yes. So if we talk about the digital manufacturing, like it is use of like integrated computer based system, right? So it includes basically simulation, 3D visualization, then analytics and like collaboration tools like for creating I can say manufacturing process definitions, like so it this approach like allows basically the manufacturers we can say to design or optimize the products and production process in virtual environment before physical production begins. Okay, so that basically the main motto of is having to reduce the cost, to improve the efficiency and like speed up the time like to market. Okay, so while so basically the thing is that by leveraging digital tools and technologies, so manufacturers will create digital twins of their products and production systems. So then it simulate various scenarios like and test different configuration even without like disrupting actual production process. So basic finally like it will lead to more informed decision making and better outcomes for both product design and manufacturing. Okay, so the right option will be digital manufacturing, right? Then the next will be value chain management focuses on minimizing resources, assessing value at each stakeholder function along the chain. Yes, we have talked about also that supply chain management or value chain management, which is basically focusing on so that the resources can be minimized, or like each stakeholder like a function along with the chain would be minimized, right? So the right option will be true. If we go to the next part, the use of IoT sensors in a manufacturing equipment enables condition-based maintenance alerts. So we have talked about IoT, right? Internet of Things, which basically what it does, it refers to the interconnected network of physical devices, right? So through like embedded sensors or softwares or networks connectivity, right? So in that context of manufacturing, like IoT sensors are used to monitor performance and condition of the like of an manufacturing part, or like of an process or equipment in real time, right? So main motto of that is the real time observation. So it provides valuable insights to like health of machinery, as we have discussed about it, right? And alert the maintenance teams to potential issues like before it becomes like critical. So that is how like condition based maintenance strategy like works. Like it monitors the condition of equipment and performs maintenance tasks only when it is necessary. So by using like IoT sensors to collect data on equipment performance, so it basically helps manufacturers avoid like it avoids the costly downtime and unnecessary maintenance tasks, right? So the correct option will be true only. Then if we talk about next question, that is IoT in manufacturing can enable the monitoring of production lines starting from the refining process down to the packaging of the final products. So any guesses what will be the correct option for that?
True.
Yes. Already we have talked so much about IoT, right? It enables monitoring the production lines in manufacturing from refining process down to the packaging of final products. So by embedding IoT sensors in production equipment, you can tell like manufacturers will collect data on various aspects like of manufacturing process in real time, such as you can say for example temperature data, humidity, pressure, vibration data. So those data basically will be then analyzed to identify patterns, or it will optimize production process, or like it will improve quality control. So for example, if you say for an example, like manufacturers like use IoT to monitor performance of individual machines, or like even the entire production line, you can see. So it predicts equipment failure before they occur, as we have talked multiple times about that. So that is how it is, the statement is obviously it's true, right? Then the next question, if we talk about IoT cannot collect the aggregate product data and other third party syndicated data from various stages of a product cycle. What do you think, the statement is true or false? Anyone? We have talked much about IoT, right? Now you should tell the right option.
False.
Yes.
False.
So obviously like it can collect product data and like third party data from various stages. Actually, so we have talked about that, right? If we connect IoT devices to the internet and like cloud based platforms, so manufacturers will easily like collect, store and analyze like amounts of data from various sources, like including if we say that sense IoT sensors, third party data sources. Say if you say for like example, manufacturers use IoT like to collect the data on customary usage patterns, right? Product performance or environmental conditions. So it helps them like to identify opportunities for improvement and innovation, right? So those data will be used to predict customer needs, or say for example it will be used to improve the supply chain management process, then optimize the production process. So obviously that statement is false, right? So if we move to the next question, that is IoT sensors are not useful for manufacturers for gaining insights into the usage patterns and handling of products from multiple customers. So, what should be the correct option for that? What do you think? It should be false, right? So, those like sensors are useful for manufacturers for gaining insights from the usage patterns, like handling products from multiple customers, right? So if you embed IoT sensors to like manufacturers products, like manufacturers will collect data on how like customers are using their products, so it will help to identify like where the improvement is needed, right? So even like if you use IoT to track product usage patterns, or like identify some problems, or you want to collect the feedbacks from the customers, so then the data will be collected and it will be used to improve product design, optimize product process, it will enhance like customer satisfactions. So obviously the statement is false.
Ma'am, just can you go to last sentence, last question?
Yeah.
The last one was a bit tricky. Why I thought means maybe that's why I need some guidance.
Okay.
So IoT sensors is usually like we are in a factory, and then you said that if factory instruments will have a sensor fitted, everyone will have IP address, right? So I could visualize still that okay, they are discussing communicating with each other. Yeah,
Yes.
that
Yes.
is okay. But the next one, that how that can be useful to products in the customer. Are you fitting some sensor inside the product which will be used by customer, and then it will collect? Let's say I am a manufacturer of mobile.
Okay.
Then and I sell my finally my product is mobile. It goes to some customer. How will it be helpful? IoT will be helpful to gain
Like it will.
usage pattern of the customer.
Yes. So actually, what it does, like it will collect the data, like basically it will read the pattern of your product, right? You have that mobile, so it will read all the patterns which are similar in the product, right? And it based on the data it will collect from that pattern, it will try to like try to get the feedback also from the customer. Basically in real time you are collecting the data, so the feedback will be received. Based on the feedback it will decide, okay, the feedback based on the feedback it will read and it will say like, okay, maybe I need here that improvisation, I need to improve here, so based on that you will improve. Again it will be sent and again the feedback will be, so that is how it works in the customer side.
Okay, so that means can I make a general statement? So I'm really, I am not expert in this, so
No,
that's why I
no.
want to understand.
Yeah.
So can we make a general statement that IoT is not only works inside the factory but also outside the factory,
Yeah.
right?
Yes. 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 Yes.
Okay, okay, clear. Thank you, thank
Basically
you.
what it does, like it tracks the product like patterns, yeah? And then like it identify if there is any problem or not, if, and then it along with that it will collect the feedback of the customers, then it will work on those datas, like from the customers it will also get the data, so then from those data it will work, so it will work again to product like improve that product design, so it will again modify the data and optimize their process, and again it will work on that optimized process so that it can like
Okay.
improve the downtime, or like improve the optimality or improve the process.
Perfect. Just one last question, really sorry.
No,
So
no, no,
let's say
it's
I have sold that mobile, right?
okay.
And ideally with IoT, I should also be able to know, okay, now its battery life is coming to an end. That
Yes.
customer's mobile, right?
Yes.
I need to make so, and I have data across the globe, and so I need to have now 10,000 batteries ready. That kind of thing I should be able to collect. Am I correct?
Yes. Yes.
With
True.
IoT, with the
Yes.
help of IoT. Yeah.
Yes.
Okay. Thank you very much. Thank you.
So if we move to the next question, that is like a fill in the blank, which is a term used to describe data centers available to many users over internet. Okay, so basically what is be the right option for that? So we have talked about cloud computing, right? So it is the term which we have seen, like it is used to describe the data centers like which are available to many users over internet. In cloud computing, what happens, like users access and like use computing resources with such as like servers, then storage applications, so even on like demand from a provider's data center, so rather than having to build and maintain their own infrastructures. So cloud computing, what it does, it offers number of benefits, include like scalability, flexibility, cost effectiveness, so ease of use. So that is how it is used in when in large scale of manufacturing industry, in data storage like application hosting and data analysis. So that is how the cloud computing is a term which is used to describe the centers available to many users over internet. Okay, so it can users can access and use computing resources like servers, storage applications, then providers data centers. Okay, and then like over internet it can manage that users, right? So that is the correct option for that. If we talk about the next one, that is cloud based manufacturing, like yeah, manufacturing enables a system to record overall equipment effectiveness to the machinery, providing insights into which areas are performing well and which needs to improve. We have talked about that, right? So it is obviously a true statement, right? Basically what it does, like cloud based manufacturers like enables that system to record overall equipment effectiveness, that is OEE, equal to machinery. So it provides like an insight into which areas are performing well and which needs to improve, as is the question has been asked. So by collecting data on equipment performance and downtime in real time data, so cloud based systems help manufacturers to identify areas for improvement and optimize the production process. That is how it whole works actually. So it measures the productivity and efficiency of manufacturing equipment that you need to optimize, right? So it takes like into account factors like such as availability, performance, quality. So it provides a single score, you can say, which will basically tell you that, or which will represent that overall effectiveness of the equipment. Based on that score only, so it will be decided like, okay, these parts are performing well, or this in this part you need to improve, and then you need to optimize the process. Okay, so that statement is true. If we talk about the next one, okay, then before going to big data, if we talk about like smart manufacturing, we have seen about that artificial intelligence are there, in the international internet of things are there, then robotics, condition monitoring, cyber security. We have like talked about that little bit, we have got that overview of that. Now that one is big data, which we have seen in the introductory part also. So big data is basically refers to like to large set of data, like uh, cloud computing, where like cloud computing refers to platform for accessing large sets of data, right? So even like big data is information, while cloud computing is like means of getting information, right? So big data is basically an information which you are getting, or cloud computing is like you are getting the information, right? So that is what the difference is. So big data is basically voluminous large sets of data, and cloud computing is the platform for accessing the those large sets of data. So basically that cloud computing is a platform, and big data is the data sets. Okay, so that is the difference between that. So advances in like connectivity, cloud computing, big data, then internet of things, which like even which are the main component of, we can say, of intelligent manufacturing system, right? So those that is the thing. And then another one is the virtual reality. Basically we have seen like in computer design packages, like in graphics programs, it can like display realistic image on your computer screen of that product or of that equipment or of that system, right? So that virtual reality, by this virtual reality, you can integrate the computer integrated images with real world, like, or scenario, or create an entirely new world, right? So that is the virtual reality. And then cyber security, we have already seen about, talked about that. So the next question, if we talk about that, that is question 10. Okay, so one fill in the blank is there. It's a field that treats ways to analyze and systematically extract information from the data sets that are too large or complex to be dealt with the traditional data processing and application software. Okay, basically for dealing with the data analysis part, those are like traditional data processing application softwares are there, right, where you can process the data and you can analyze the data. But like for complex datas, or like for large number, like from data, too much large datas or complex data, so for that, like big data is field where like it is, those datas are analyzed. Okay, so basically big data, it like actually involves use of advanced technologies or techniques, such as, we can say, machine learning, then data mining, artificial intelligence. So it can handle even deep learning, that neural networks, so it can handle a large number of data sets to extract the information from that, right, to predict the output. So describe data, like data sets which are so large, we can say, in complex, which cannot be processed by normal data processing applications. So the right option will be big data. Okay.
Just one curiosity out of that. So
Okay.
big data was pretty clear. The only, in fact, huge data was not the answer. Not all. That was also not the answer. But the only slight confusion likely to take place is with the data computing. So computing is what? It is again a means, na? It is not info. Big data is a info, while data
Yes,
computing is also a means, right?
it's a platform actually, you can say.
Okay. Okay.
So
Platform. Data
yes,
computing is a platform.
yes, it's a
Okay.
platform. But big data is the number of data sets which you
Yeah,
are
yeah,
having.
yeah. Okay, okay. Huge. So, like, we get a census data,
Okay.
100 crore people of India. So that will be a big data, right?
Yes.
We
So
can call it as a big data.
yes, and if you like process it through some machine learning algorithm, or say through some neural network, you will get your required product, like predicted output easily,
Mhm,
right?
mhm,
But you
mhm,
can't use some traditional data processing, because you are saying that I have 1 crore data.
mhm, mhm,
That is
mhm,
the
mhm.
thing.
Yeah, 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 yeah.
So if you move to the next question, that is the question number 11. Okay. Yeah. So which of the following areas can have the application of augmented reality or virtual reality? So basically what it happens, like you can say, okay, complex assemblies, maintenance, I'll come one by one. First
Okay.
talk about like you have like seen about that, what is called virtual reality, right? So now what it like does it mean that augmented reality? So basically what it does in augmented reality, users control their presence like in real world. Okay, and virtual reality, users are controlled by the system. Okay, in virtual reality, systems basically control the users, and in augmented reality, like users control the presence in real world, right? So like what it does, like virtual reality requires a headset device, but augmented reality, it can be accessed is accessed like without this, right? So that is what, like if we talk about virtual reality also, we have seen in the slides also, like if we talk about that virtual reality, it's like you have computer aided design packages, right? CAT packages we have seen in the previous lectures, and graphics program you have. So it displays basically a realistic image on your screen. So by like that image, by referring that image with real world, you can create like that entire new world, or like you can immerse that user in completely computer generated world, right? So that is what that virtual reality is. And augmented reality, as I have already talked about, that it like here like you can control the presence in real world only. Okay, so that is the difference. Now if we come to the questions, mm, just a minute.
Ma'am, can you please repeat that sentence? In AR, users control the uh,
Actually, in AR, like users control the present scenario of your real world.
scenario. Okay, okay.
Yes.
And in VR, it is the scenario which will control you,
Yes,
user. Okay.
actually here you can refer the CAD package that design you are making in CAD, right? So that you can refer and you can take it to the real world scenario. You can like you can display that real world scenario in your computer screen only. You can refer that. Okay, so if we talk about the question, that is basically what it does in like just a minute. Okay, so like even like on virtual like reality, or say for example in augmented reality, like users like engage with virtual interactive environments. So they overlay virtual components with their physical environments, right? So the thing is that where the options, which of the following areas can have the application of augmented reality or virtual reality. Okay, so the like the in complex assemblies, if we say for example a complex assembly you have, right? So like augmented reality and virtual reality, it can be used to provide workers with like digital overlay of information and instruction, right? So it allows basically to visualize and like interact with complex machinery and assemblies in a new way. Say for example you have a complex assembly, or that machine is having a complex or like um, complex assembly which you want to visualize or which you want to interact with it. So what we will do using that digital package of CAD softwares, you will try to overlay with that information, or like of that you will try to visualize the real machinery, right, or that complex assembly. So it what it does, it will improve the efficiency, accuracy and safety, right? So in maintenance, when augmented reality or say virtual reality, it will be used to provide technician with digital overlay of that equipment or of that complex assembly. So it will help them to diagnose and repair problems more quickly and effectively by like first analyzing that digital overlay which you are preparing in CAD package. So the complex assembly, maintenance, expert support, all of these are the right option. In expert support also, it used to provide remote experts with a real-time view of equipment, and you can remotely access this digital overlay of that complex assembly, and like you can get the support from that experts like in real-time view of that equipment and system. So it will like provide you a guidance and support from afar, right? So the correct option will be all of this. Basically what it
Lovely.
does, like it will read the digital design which you are making of that complex assembly which you are having. So you will study the digital representation of that, and based on the expert supports and in real time data, based on you are getting some inputs, and you can even in maintenance also you are getting some insight from that display, and also in assembly also you are getting some insights from that. So we'll get to understand about that assembly which you are having. So that is what the significance of virtual reality is. So virtual reality reduces risk and can accelerate implementation by allowing engineers to quickly identify problems. Yes, it's true, right?
Yes.
Yes, so it can reduce risk and accelerate implementation, which allows engineers to quickly, like it will identify the problems, right? So like it creates a digital model of that, and as we have talked about that, and from that in virtual environment will uh, analyze this that with display of that which virtual display of that, and we'll make it to understand like whether that maintenance is required for that or not, and to minimize the risk of that machinery, right? Then comes to the last question, that is fill in the blank is given, that is the protection of computer systems and networks from the theft or of a damage to their hardware, software or electronic data, as well as from the disruption or misdirection of the services they can provide. So cyber security, information technology security and computer security, so we have talked about it initially, right? So cyber security, say information technology security, and then computer security. So those all are the terms we can say which are used like to describe protection of computer systems or networks, so from theft or like damage, disruptions or misdirections of data, softwares and hardwares. So like because those datas are used interchangeably, right? So there's those refers to some basic concept we can say for protecting our computer systems or networks from cyber threats. So it can take many different forms, say for example it includes uh, like that malware, then service attacks. So it like effective cyber security or like information technology security or computer security, so it requires range of different strategies or tools. So if it includes firewalls and antivirus softwares, then intrusion detection systems, so encryptions. So the right option will be the all of this, right? So those are the questions which are being asked in previous years as well as this year also. So I tried to explain all the questions which are there. So apart from that, any doubts or anything, like I guess.
Ma'am, in exam also the questions, I think on 29th exam is there.
Yes.
So in exam also similar, means I'm not saying same, but questions will be similar, right? Same methodology, right?
Yeah, you will get the questions from that lecture notes only. So apart from that, I don't know in detail about that.
Yeah. But it's MCQ only, right?
I don't know about the question patterns actually. It will be based on the
Okay.
instructor only.
Okay. No, thank you.
Anything else? Shall I close the meeting?
Just one question.
Yeah.
So about AR and VR, let's
Okay.
say I'm getting two examples in my mind. Can you please
Yeah,
guide
sure.
me if they are correct? So let's say now we see many times people wearing AR VR goggles, and then they are just in some simulated environment, and they feel okay. They touch, actually they make hands and gestures and all that, but actually nothing is there. So
Okay.
that is the virtual reality. Am I correct?
Yes. So
And
yeah, basically
if
you are getting you are displaying your system in a CAD package or say in virtual world. So you are assuming that okay, it is your product or process, and then based on that you are getting the decisions, or you are taking the decisions. Okay, whether the next steps will be what will you need to take the next steps based on that.
Okay, okay. And AR, then AR would be, let's say I have a joystick and all that, and those cameras, and I'm actually flying the drone. So I'm sitting here, but flying the drone. So and I see that drone here and all the environment. So as if from the cameras fitted inside that drone, but I'm sitting somewhere else and I'm flying that drone. So can that be called as augmented reality?
Yes, in real world you are trying to incorporate into that data. That is augmented reality.
Okay, I'm actually flying the means
Yes.
I am flying the drone, but sitting somewhere else, and I can see the yeah,
Yes,
clear, clear.
that's true.
Okay.
Yes.
Okay, thank you, madam. Thank you very much.
Anything else? Yeah. So please share the feedback also on that. You will be shared one link also, so in that you can send the feedback.
Cancel. Have you
Yeah.
declared?
Okay. So anything else
Thank you,
or
ma'am.
okay? Then I'm leaving the meeting. Okay.
Thank you, ma'am.
Yeah. Thank you.